Coming up on 1 minute and 36 seconds until we contact Orion. Meanwhile, aboard the spacecraft, the crew has continued executing their lunar flyby tasks. As we discussed earlier today, these activities have been precisely timelined, and this is the fourth of 5 blocks of time during which the crew will be observing the moon at windows 2 and 3. One crew member is in window 2 with a blue shroud over the window, taking photos and using an 80 to 400 millimeter zoom lens, while the other astronaut is in window 3 using their portable computing device, also known as a PCD, to make annotations. And both of those crew members are making audio recordings of what they are seeing. They are wearing headsets connected to their PCDs, and those audio recordings are being sent to the science team tonight. We are not hearing those live. However, we have been hearing quite a lot of great descriptions from the crew who have been serving as the support. Right now, the support team members are Reed Wiseman and Jeremy Hansen. Those team members are providing science sit reps, situation reports, calling down a few times each hour to discuss what they're observing. And even though we're out of contact with them right now, they are still conducting those science sit reps as they'll be available once they come back around the moon. The situation reports include how the crew is positioned, any missed targets, or anything unexpected they saw. They're also including lunar target descriptions, any hardware issues, and their emotions and reactions. Again, we are standing by to acquire signal from the Orion spacecraft. We're in the Artemis Mission Control Room at Johnson Space Center, getting our preliminary contact with Orion, that acquisition of signal coming after a 40-minute loss of signal, during which the crew was flying behind the moon, out of contact with anyone on Earth. We are getting our first views from Orion after the loss of signal. Orion has come back around the other side of the moon, and that little crescent that you see is Earth, over 252,000 miles away. With this transit complete, lunar flyby continues, but Orion has also technically begun its journey home. Right now, the crew are getting a few moments to enjoy and take photos of Earthrise for themselves, and we expect to contact them shortly. But we do have good signal coming from Orion. This view from inside the Orion spacecraft, all 4 astronauts now back on the other side of the moon and in contact with us on Earth. Their tasks for lunar flyby did not stop as they went behind the moon and out of contact with us. We anticipate during that time they were attempting to image some impact flashes, short-lived flashes on the lunar surface, which would be caused by impact bombardment and potentially even lofted lunar dust. Right now, of course, they are getting pictures of Earthrise. After this target, they will get a short observation break. It's about an hour long, actually.
Houston, integrity, comm check.
Integrity, we have you loud and clear. How many?
Houston, we have you the same, and it is so great to hear from Earth again. To Asia, Africa, and Oceania, we are looking back at you. We hear you can look up and see the moon right now. We see you too. When we burned this burn towards the moon, I said that we do not leave Earth, but we choose it. And that is true. We will explore, we will build ships, we will visit again. We will construct science outposts, we will drive rovers, we will do radio astronomy, we will found companies, we will bolster industry, we will inspire. But ultimately, we will always choose Earth, we will always choose each other.
Integrity from Earth, our single system, fragile and interconnected. We copy. Those of us that can are looking back.
We are happy to say we copy.
Those first communications back with the astronauts aboard Orion. Christina Cook calling back to what she said just before translunar injection burn, that with this burn, we do not leave Earth, we choose it. The translunar injection burn served as not only what put them on this trajectory to fly around the moon, but what also committed them to splashing down in the Pacific Ocean on flight day 10. At this time, the crew is entering an observation break. We expect this to last about an hour, and it's probably a welcomed break following their very, very busy day taking pictures, making annotations, making audio recordings, and communicating all of the wonderful things that they are seeing on the moon. This observation break is also partially due to the fact that we will be entering an eclipse later. This will be the first solar eclipse that humans have seen from the moon. The astronauts will need to wear eclipse glasses for the first 2 minutes until the sun is completely covered by the moon, and then they have additional targets that the science team is hoping that they will photograph. We will have communications with them during that eclipse time frame. Because of that eclipse, Orion's attitude must be changed right now so that its solar arrays are in the sun. This will help it charge the batteries needed to power it through that eclipse time frame. This view on your screen is a visualization. The spacecraft now 4,224 miles away from the moon, and that number will now continue to grow, while the number of distance from Earth, 252,699 miles, will continue to shrink all the way until our crew is back home. Again, we are MET, mission elapsed time, 5 days and 58 minutes since the launch of Artemis 2. We have reestablished communications with the crew and the Orion spacecraft, now entering a little bit of a break while they are out of visibility, or the moon is out of their visibility. The spacecraft will be reoriented to view the moon ahead of an upcoming eclipse. This current attitude maneuver helps charge the solar arrays and batteries aboard Orion that will power them through the eclipse.
Integrity, Houston. In mission control, all of your flight controllers and your flight director have flipped their Artemis 2 patches around. We are earthbound and ready to bring you home.
That's great. Great to see the light of day as we head back to
A very special moment just now in mission control ahead of the crew's flight to Kennedy Space Center, and during one of their last sims or simulations here, they visited the mission control team in Artemis Mission Control in Houston and brought us each a patch. Everyone in the flight control room has had these on their signifiers at their console. On one side of the patch that you've probably seen is the moon with the Earth behind it. Now that we've passed behind the moon and we are returning home, the flight control team has instructed everyone in the room to switch their patch around so that the Earth is closer and the moon is behind us. We are really looking forward to seeing the Artemis II crew, and the Capcom Jenny Gibbons did call that update up to the crew that the flight control team here has turned their patches around as was instructed by the crew during that last sim, and we are counting down the days until they get home. They are now 5 days, 1 hour, and 3 minutes mission elapsed time into the Artemis II mission. Joining me here in the room, Artemis Mission Control, I have Angela Garcia, Artemis II Science Officer. Thanks for being here, Angela.
It is an honor to be here. What a day. Everyone Phone's buzzing. I can't contain myself. So it's been a really awesome day.
So you're sitting on console at the science console now. Have you been in the SIR earlier today?
There's a lot going on. So I went here first, then I'm going to go there after.
Houston.
All right, Integrity, we hear you. That was a little clipped, but I think we have a better link now. We experienced some blockage from a solar array. We moved it. And we are in bias, tail to sun.
Okay, Houston, you're coming in loud and clear, and copy, we're in bias tail to sun now.
Affirm and Integrity, just so you know, we did not hear your response once we flipped our patches. Jeremy, we heard you call down, but you were clipped, and then we briefly lost comm. Glad we're back.
Okay, copy that. We were just excited that we got to share in that you, the MER, and Mission Control flipped your patches around, and that side of the patch is getting to see the light of day. Okay, thanks for sharing that with us.
Our pleasure.
Okay, Angela, so can you tell me a little bit about your role supporting Artemis II and the science preparation for the mission?
Yes, so I'm one of the 3 science officers. So Kelsey's been on console all day. I'll take over kind of closer to the end of the day. And then Trevor Graff is on the planning shift. And so it's the 3 of us in this 24-hour cycle supporting the mission. And so the Science Officer console is a brand new console to Mission Control. And not every day that you get a new discipline incorporated into Mission Control. So it's been such a significant milestone for us, and it's just a testament to like the commitment that the flight operations directorate and NASA have, that they're going to be integrating science and maximizing science throughout Artemis. So it's really exciting. And then the science preparation Yeah, so I'm on the operations team, but I'm also on the training team. So all the incredible training and shout outs that you've gotten today, it warms my heart. It warms everybody's heart in the science evaluation room. I promise you that. But so all the classroom training, the field training, the mission simulations. Right? We were part of all of it, and that is what we did to get the crew to be. They are a part of the science team, and they are the forefront, that nice edge, and they're just been doing such a great job today.
I know. I imagine that you have to be pretty. Their reports have been fantastic. So I would like to know a little bit about how you have developed procedures for this crew. What kind of science activities are they carrying out inside the spacecraft?
Yeah, so the procedure development has been a unique challenge. I would say the exploration science that we're doing is inherently pretty flexible, and operations is, I'd say, inherently has more structure and rigidity. And so to marry the two and to operationalize the science that we want to get done has been a challenge. But I think we've been able to go through these processes and create good products at the end and have a good plan. And yeah, it's been really great. What was the second part of your question?
Just what kind of these science activities that they're performing, which of those have you really had a hand in?
Yeah, so a lot of the procedures help organize what the crew is doing in the cabin. And I know we've talked a lot about, what they've been doing, and they've been doing a lot. And it's been a little dark, so I can re-explain what some of those things that they're doing. So the observation blocks are about an hour long, and the crew is organized, the 4 crew members are organized into 2 pairs of 2. The window team and the cabin team, and the lunar targeting package that you've been showing up, and that the crew have on their handheld tablets is really the instructions for the window team. So the window team, the 2 crew members are looking out the window. One has the camera with the long lens. One has, they're just looking out the window with their unaided eye, and they're taking these detailed observations. And then halfway in that observation block, they do the window team position swap. So that's what Capcom's been calling out, and they'll switch positions, so each crew member has a chance to have that long lens, and then that's just what the window team is doing. There's also the cabin team, where they also have duties that they're doing. We're asking a lot of the crew in this time, and then the cabin team, they have the interior camera, and they're taking images inside the cabin. They're also supporting the window team, where, you know, you've heard some call outs where looking out at the bright moon and then looking inside the dark cabin and looking at their LED screen is a lot. So the cabin team is also helping support, target, and guide the window team into specific targets on their plan. They're also helping call out these science situational reps. So they're looking out a different window and listening in to what the crew who are really down and in the science on the window team are doing, and they're giving us insight. And those recordings that the window team is doing are going to be uplinked or downlinked overnight, and we're going to be able to chew on that data. But yeah, they're helping. They're doing a lot, and so making sure we have a plan and that's flexible, but also make sure that we check off all those boxes was really important.
So tell me a little bit more. You talked earlier about the analogs that the crew has done. What kind of analogs or environments were really useful for this?
Yeah, so for procedure development, right, you have so many different environments that you can do. You have classroom, like we said, we have you have the Orion mock-up, you have simulations, and at least for developing the plan, we kind of did it in a tiered approach, because each of those different analog environments helps us answer a slightly different question and has a little bit of a higher fidelity. So we would start with the classroom. So we would get, we would just get into a classroom, we would put all the hardware on the table, and then we'd almost role play of like, you be Victor, you be Reed, you be Jeremy, and I'll be Christina, and like, let's just do the plan how we think we should do it, write that down, and then just keep iterating on that, and then
Integrity Houston for a tag up pre-forward link LOS in place of the Flight Director Conference.
Okay, Jenny, we're ready.
All right, crew, I'm going to roll through a couple of topics here. The first two are for timeline. First of all, read for your toilet maintenance. It is a short toilet maintenance where you do not have to do the oxone changeout. That portion of Victor. You have an HHP stop activity on your timeline. We need you to perform that as scheduled for bandwidth reasons. For your next portion of the flyby, in particular the eclipse, we want to remind you that you can take off the eclipse glasses when the sun sets and you are simply looking at the corona. And finally, for the D5 with the long or zoom lens, which is set for solar corona, we want to remind you that when you are capturing Earth shine, you will likely have to adjust the exposure. That's all I have for you. Let me know if you have anything for us.
Okay, Houston, we copy all. Thanks for those words, Sydney.
All right, just a quick call up to the crew ahead of a forward link LOS, meaning that we won't be communicating with them, but we will be receiving their communications and data during that time frame. So, Angela, we were talking about analog environments. You were telling me about the classroom and getting in there and pretending who's Victor, who's Reed. Tell me more about this.
Yeah, it works pretty well. So you the plan how you expect it to be, and then once we finalize that plan, we'll give it to a completely new group of people and have them practice it, and then they'll be like, these steps don't make sense, and we'll reiterate on it over and over. And then we'll take it to a higher fidelity environment like the Orion mockup, and we'll do the same thing because that volume is smaller. The window placement, their seating, what things have we forgotten? With this, addition of this this environment, and then once we, reiterate on that, we'll take it. Then we'll give it to the crew and have them execute off of it during mission simulations. That's the highest fidelity that we can do before we send it to space. So this is the first time we've had to do this because we're a brand new console, and I'm just. It just sparks so many neurons of like, how are we going to do this for surface missions? And integrate this in so many different ways. So excited to have kicked off this process. But there's so much more to come.
Fascinating. And I think it was really well thought out too, because each crew member gets an opportunity to do each task. And so you're getting different perspectives and different insights from each crew member, maybe even about the same target, but something that one person sees could be completely different than something another person notices. So we also know that Artemis 2 has traveled on their way home, but they traveled farther from the moon than the Apollo missions did. So what makes that vantage point scientifically interesting?
Yeah, observations are so fundamental in the scientific toolkit, particularly observations from different perspectives, different scales, and with different techniques. And so for this, so we really tried to make the plan to optimize those. There's pros and cons for all those things for this mission. So we really just focused the plan to have all those pros. So in terms of scale, this zoomed out scale, you can learn different things. This zoomed out, or this different perspective. So their perspective, as Kelsey talked about photometry around when they orbit the moon. And then also just their different, the different things they're able to observe. So yeah, let me talk a little bit about scale, because I think observations at different scales, you can gain a lot of different information. So like, for example, if you were an astronaut on the surface looking at a rock, and you describe at this micro scale. So in training, we kind of talk about observations from micro to macro, or from outcrop to orbit. So looking at, a rock at this scale, you can describe its components, you can describe what it's made of and its colors and its minerals. And you're like, okay, and this rock came from this boulder, and it's this part of this boulder, and these are the different things that I'm observing around. It gives me context to this sample. And then you zoom out a little bit more and you're like, okay, well, I can see that this boulder came from, it rolled from this mountain ridge or this high ridge feature. And then because I can see the trail that it came from, okay, now let me describe this ridge and different parts in it and maybe other boulders that I'm seeing. And then you zoom out further of the orbit scale and you're like, this ridge is a part of this larger crater. So all of those different steps give you different information. And so that's why observations at these different scales and these different perspectives are so important. So this zoomed out kind of far view is this full lunar disk view. It's the full lunar, on Earth we see the full lunar disk as well, but now we're able to see it on the far side, and we're able to see it, all at the same time, which enables the astronauts to compare quickly to different parts of the surface. And color particularly is very compelling because you can just very quickly compare from 3 different regions. Is it in the same family? Is this actually a little bit different? Compare that to what they see in their orbital data that they have access to on their portable computers, and really just be able to tease out that nuance and information.
Yeah, we heard them make a lot of those connections today, and especially the color. We talked with Kelsey about this a little bit, just how exciting it was to hear the browns and greens and things like that. I cannot wait to see those pictures. Yeah. So one last question. We are coming up on the last lunar observation block, and this is when we are going into a solar eclipse. So can you tell me what you're interested in the crew learning during that time frame?
Yeah. So the data set, yes, there's so many things. I had to pick one. So I'd say the thing that I'm most interested in seeing is the annotations that they're taking. So in this opportunity, it's a very dynamic type of experience in that we don't normally see this activity. So being able to have crew observe the solar corona and then also annotate it in their on their portable computing device is just such a unique thing that humans can give to missions, and also particularly being able to annotate what they're observing while they're talking about it is also unique to being able to have astronauts in orbit as well, because we won't be able to have annotations on the lunar surface because the astronauts will be in suits. They're going to be collecting samples, they're going to be deploying instruments, and see how that develops over time, because you've heard a lot of descriptions, and I think when people are describing something that's unique and different, you can interpret it differently. If you're drawing and you're marking, particularly color provinces, for example, and those boundaries, you know exactly what they meant. And really, I'm just very excited about those annotations. There's some annotations that the Apollo crew have made, particularly about solar coronas and the structures that have, and lofted dust that have given a lot of, with the community of they're observing this phenomenon, and now it's our job to hypothesize of why are they observing this, what is going on. So I think that's just a really cool part of exploration and science, and this beautiful thing that we're about to do.
Well, now you've got me excited about the annotation too. I mean, I'm excited about the pictures and the audio. No,
don't sleep on the annotations. I am very excited to see these little sketches that they're able to draw, and we have pictures that they can just draw right on. It's this particular thing is different than what we've seen. So I'm excited about that.
I'm excited too. Angela Garcia, thank you so much for joining us today, and have a great time tonight on console.
Thank you, and you've been doing a great job, and it's so excited to see where we go from here.
Thank you so much.
Integrity Houston, you have 3 minutes until we go into a forward link LOS. We will be back up with you in about an hour during the eclipse on Madrid.
Thanks for the heads up. Look forward to seeing you on the other side.
Likewise.
We're live in Artemis Mission Control at Johnson Space Center in Houston, Texas. This is a live view from the Orion spacecraft with our Artemis II crew inside. That's Reed Wiseman, Victor Glover, Christina Cook, and Jeremy Hansen. We are still live for our lunar flyby coverage. The crew is in a short break while the spacecraft is pivoted away from the moon. We are going to be going into a solar eclipse. This is the first time anyone has ever seen a solar eclipse from the moon. So it's going to be a unique vantage point for our crew. But ahead of heading into that solar eclipse, we need to charge the batteries on the Orion spacecraft. Therefore, we have positioned the solar arrays into the sunlight to allow time for those batteries to charge. We will get back pointed at the moon just in time for that solar eclipse. We are also in a forward link LOS. What that means is essentially we cannot send calls or commands to the crew right now from the ground. However, we clearly get all of their data and communications. The spacecraft is now 4,632 miles away from the moon, and that number will only continue to grow as the distance from Earth shrinks, now 252,523 miles away. Our closest approach to the moon today was approximately 4,067 statute miles in altitude. Our maximum distance from the Earth is suspected to be 252,756 statute miles. Both of those moments came while Orion was flying in their loss of signal time frame behind the moon. The crew also set that new record today, beating the Apollo 13 record of distance from Earth. This is an animation or a visualization that you can track anytime, day or night, by visiting nasa.gov/track-Artemis. This shows you how the spacecraft is positioned as well as their distance and velocity. Now traveling 930 miles per hour. During this break in their time today, the crew is working on a couple of other tasks. Some of those include their National Geographic timelined test. National Geographic was selected through a competitive process by NASA to help tell the story of Artemis II. So you've seen the crew with some GoPros inside the cabin, taking videos and pictures, and with other cameras as well. National Geographic plans to leverage its portfolio of media assets, including magazines, social and digital content, and television programming for engagement opportunities. Throughout the flight, the crew has been timelined a little bit each day to film from a shot list provided by National Geographic, and that includes their morning routine, talking with their families, exercising, and just their overall thoughts about the mission. And I cannot wait to see that footage. Teams on the ground reporting that the spacecraft is looking good and that the power aboard is good as well, all setting us up in a proper position before eclipse. The crew is in a little break during our flyby coverage for today. They will resume their flyby momentarily in about 30 minutes once they get into their observations during that solar eclipse. Now, the moon is our nearest celestial neighbor, orbiting Earth at less than 250,000 miles on average. When our astronauts venture there for future Artemis missions, they'll target landing sites near the lunar South Pole. There, ancient rocks, minerals, and trapped water ice will not only provide resources for human explorers, but they may also contain clues to the formation and evolution of our planet and the solar system. Let's learn more about the lunar South Pole with this video featuring Dr. Kelsey Young, Artemis Science Flight Operations Lead.
We learned a lot from the Apollo samples, but we still have a lot left to learn about the moon. The Apollo missions visited only a pretty narrow swath of the moon. All the missions were concentrated near the near-side equator. Really interesting and really critical insights were unlocked with the Apollo samples, but we have so many questions still to answer about the moon and the evolution of the moon.
And liftoff of Artemis 1. We rise together back to the moon and beyond.
NASA's Artemis missions are NASA's plan to send people to the surface of the moon. We'll be sending people and roving assets and scientific equipment to, among other things, answer a lot of really compelling science questions. Scientists have a lot to learn about the moon. It's our nearest celestial neighbor here to Earth, so what the moon has experienced, we've experienced. Except here on Earth, we have things like plate tectonics, oceans, forests, people that erase the rock record. Whereas on the moon, that whole record of our planet's history, of the moon's history, is just kind of waiting there at the surface for us to explore. The South Pole, which is where Artemis missions are going to target, is specifically interesting for a couple key reasons. We think there are volatiles at the South Pole of the moon that are not present near the equator. Things like water and water ice that are trapped in the lunar regolith, which basically just means lunar soil, that can easily be untrapped from that lunar regolith, and scientists can scoop up and study for return to Earth. The lunar South Pole is a really exciting scientific target, and it also comes with some challenges for operating. For example, the lighting environment will change drastically within the course of one mission, and even over sometimes the course of one spacewalk. So preparing the crew members, preparing the hardware that we're sending to the moon, and preparing the mission control teams is really, really important. The South Pole Aitken Basin is particularly exciting. We think it's one of the oldest and largest impact basins in the solar system. And if we can get the right rock from the South Pole Aitken Basin and bring it back to our labs here on Earth, we can use that sample to constrain the entire evolution of our solar system and really understand the timing of how the moon and our planet and the entire solar system evolved.
You're looking at a live view aboard the Orion spacecraft of the Artemis II crew, working in the middle of one of their breaks or the flyby period. Coming up next will be that solar eclipse. Throughout the Artemis II mission, and of course throughout today, you've likely heard the crew being called with the name Integrity. The Artemis II crew members named their Orion spacecraft Integrity during a news conference September 24th, 2025. The name Integrity embodies the foundation of trust, respect, candor, and humility across the crew and the many engineers, technicians, scientists, planners, and dreamers required for mission success. They said this name is also a nod to the extensive integrated effort from the more than 300,000 spacecraft components to the thousands of people across the world that must come together to venture to the moon and back, inspire the world, and set the course for a long-term presence at the moon. The crew also said that integrity is rooted in a shared core value of NASA, the agency's astronaut office, and the CSA, the Canadian Space Agency. We are 5 days, 1 hour, and 38 minutes mission elapsed time into Artemis 2. In this view on the screen, you can see the crew starting to even look through some photos that they may have captured today. We really look forward to sharing these photos with you as soon as we possibly can. And the best way to keep up with those is to follow NASA on social media. You can do so at NASA, and for this mission specifically, at NASA Artemis. Again, we are in a forward link LOS, or forward link loss of signal with the crew, meaning that we're not able to communicate or send any commands to them right now as they were. This is a tracked event that occurs at times, but they could still provide communications down here to us, and we are obviously still receiving their video and their data.
Houston, integrity in the blind. High priority PAO activities on Reed's timeline are on PCD1 in a folder imagery for downlink, and then high priority standby imagery for downlink, and then lunar flyby for PAO, and then high priority PAO. Thank you.
This is Artemis Mission Control. You heard Reed Wiseman, commander of the Artemis II mission aboard Orion, make a call in the blind. This means he knows we cannot call back and that he knows we may not receive his call. However, we have good communications with the spacecraft. They just cannot hear from us right now due to a forward link loss of signal. Again, we were tracking that this would occur, and we will regain that momentarily. But that call that came down from Wiseman mentioned some imagery, so we are very much looking forward to getting pictures taken from the moon today. Again, to see those images, make sure you follow NASA on our social media at NASA and at NASA Artemis. The view on your screen right now is an animation. This is called ARROW, or Artemis Real-Time Orbit website. You can visit this for yourself at nasa.gov/trackartemis, and you can watch as we continue to grow closer to Earth and farther away from the moon. It's all seemed to happen so fast so far, and we're coming up on splashdown now in 3 days, 23 hours and 31 minutes. This is Artemis Mission Control. We are in a forward link LOS with the spacecraft. We're not able to send commands or communications to them right now. However, they could send them to us, and we do get spacecraft data. This is tracked as we are on the Deep Space Network. This is the network that we use to communicate with the spacecraft now that we are so far from Earth, over 252,000 miles. We are still in our lunar flyby coverage. The crew still have a very important and very exciting flyby milestone coming up when they will see a solar eclipse from the moon, the first humans to ever do so. Something that we also have to consider when it comes to our missions and launches is space weather. So since the Apollo 16 and 17 missions, there were some solar eruptions near that time frame that could have been dangerous to our explorers. Over those 50 years since those storms, the data, technology, and resources available to NASA have improved, enabling advancements towards space weather forecasts and astronaut protection, which is key to NASA's Artemis program to return astronauts to the moon.
Across our planet, billions of people depend on the invisible networks that connect us to space. Every day, those networks are at the mercy of our temperamental sun and the space weather that it unleashes across our solar system. That's why NASA's space weather program tracks solar storms from the moment they erupt, modeling their paths, anticipating their impacts, and leading the research that the world's industries rely on. NASA's space weather research and modeling is driven by the needs of society and enables critical decision-making that equips pilots to reroute around high radiation areas, farmers to adjust GPS-based precision planting and harvesting plans, and power grid operators to mitigate the impacts of potential surges. For those exploring other worlds, NASA provides 24/7 space weather monitoring for Artemis crews at the moon and future Mars astronauts who may be exposed to dangerous levels of radiation during solar storms. Whether you're a pilot or a passenger, a farmer or a consumer, a power grid operator or energy customer, a satellite controller or GPS user, space weather impacts us all.
This is a live view from the Orion spacecraft on the Artemis II mission. It's now been 5 days, 1 hour, and 54 minutes since we launched. We are still in our flyby coverage, and the crew is on a short break right now as we have changed the attitude of the spacecraft to help charge the batteries aboard. We use the solar arrays to gather energy from the sun and store it in the batteries. That way, when we are not in the sunlight, we have those batteries to continue powering Orion. Now, we're doing so because the Artemis astronauts are about to experience a solar eclipse from their capsule, and this is a solar eclipse that no one else on Earth will experience. This eclipse is about 54 minutes, and to the astronauts, it'll look a lot like a total solar eclipse on Earth, except the moon is going to be huge compared to the sun, unlike when you watch one on Earth and the moon and the sun appear about the same size in the sky. We're interested to learn if they see the outer corona when the sun is fully obscured by the moon. And because of how big the moon will be from their perspective, the total phase of the eclipse will last nearly an hour. The astronauts will see a partial solar eclipse as the moon covers and uncovers the sun, which is before and after totality. So, much like us on Earth, they will have eclipse glasses so they can safely view that portion. The astronauts will also be using cameras to capture images of the corona during the eclipse. There also may be some other planets visible during the eclipse, including Venus, Saturn, Mars, and Mercury. If they can identify what part of the sky they're looking at, this can help train future Artemis astronauts on what part of the sky they're seeing. This provides useful knowledge in challenging situations when they may need to rely on that information instead of instruments for navigation and orientation. Confirmation from teams here in the ground that we have reached the eclipse attitude, meaning Orion is in the proper position to observe it. The astronauts' break during this observation period is now over, and we are resuming their lunar flyby observations. The first of these is sunset. This is the solar corona that we'll be looking for. It's the outer atmosphere of the sun. The science team is also interested in if the astronauts can see polar plumes. These are thin streamers that project from the sun's north and south poles. Additionally, they're interested in seeing if the crew can witness coronal loops. These are arcs close to the sun's surface. And something else that we've previously mentioned is lunar dust. This is dust from the moon that is lofted above the lunar surface and illuminated by the sun. It was reported visible by Apollo astronauts. You're getting a live look from Orion as the crew observes a solar eclipse from the moon. Again, this solar eclipse is only visible to the crew on the spacecraft. It's not visible to anybody on Earth. The science team is interested in several different targets for them during this time frame. And we're personally looking forward to getting those images as well. Again, during the beginning portion of this eclipse, the astronauts will need to use eclipse glasses just like we do from Earth to safely view it. Once the moon has completely covered the sun, they'll be able to take off those glasses for almost an hour. Totality on Earth during a solar eclipse lasts only a couple of minutes. So this opportunity gives them a chance to look out into deep space and to look into see if there are other planets nearby. What you're seeing right now is the solar corona. That's the outer atmosphere of the sun. And the science team is very interested in any images that the crew can capture of this. They're hoping that they'll take pictures and describe the visibility, color, and shape of the solar corona as a whole and its substructures, those plumes and streamers.
Science integrity in the blind. This is continues to be unreal. The sun has gone behind the moon, and the corona is still visible, and it's bright, and it creates a halo almost around the entire moon. But when you get to the Earth side, the Earth shine is already shown. I mean, almost seconds after the sun set behind the moon. You could see Earth shine. The Earth is so bright out there, and the moon is just hanging in front of us. This black orb out in front of us, in front of now, not the blackness, but the gray that blends and drifts into the blackness. We can see stars and the planets behind it. And Christina is in window 1, Reed is in window 2 with the long lens. And Jeremy is describing it in a movie. It is an impressive sight. The horizon where the sun set outside of the moon and Earth is very same. And it's a quite impressive visual. Well, it's amazing.
Again, you're looking at a live view from the Orion spacecraft on the Artemis II mission. Orion is now 252,125 miles away from us all on Earth. We're here in the Artemis Mission Control Room in Houston, Texas. And what you had just before we lost that view quickly was the corona of the sun peeking around the moon as the astronauts are entering a solar eclipse for this portion of the lunar flyby. We're now over 5,500 statute miles from the moon. That closest approach today was just about 4,067 statute miles away. Teams in the room beginning to get a little busier and filter in and out as we are stepping through a handover. The Orbit 1 team is handing over to Orbit 2, who will continue monitoring lunar flyby and all of the systems aboard the Orion spacecraft. You're getting your last few views of the solar corona as the moon begins to take center stage and completely cover the sun. If you see that bright dot up near the top left of your screen, we think right now that that may be a part of the spacecraft, but we'll be sure to correct that if we end up figuring out later that it is something else entirely. It has been an absolute honor to join you here today for the lunar flyby of Artemis II, the first time humans have flown by the moon in over 50 years. I'm Leah Cheshire Mustachio, and I'm excited now to hand over the
team is shifting around in the windows, and we are transferring settings on a camera to pick up Earth shine, and it is amazing. The brightness where the corona, where the sunset is still bright. I think there may still be corona visible, but that part of the horizon is still lit brighter, and you still have a distinct Earth shine.
You know our rules that we don't talk when the crew is talking, so wanted to give Victor Glover a moment there to call down what he was seeing now that the moon is covering this really amazing time during today's lunar flyby. Again, thank you so much for letting us help tell this story today. I am Leah Cheshire Mustachio, handing it over to my friend Anna Schneider at the PAO console as the 2 team comes to. Thank you so much, and I hope you all enjoy tonight. Anna, you can take it away.
Thank you so much, Leah, and it's been a joy listening to your coverage over the last several hours. So, as you mentioned, the 2 team of controllers are making their way on console and completing a 1 team of flight controllers. The Orbit 2 team tonight will be led by Flight Diane Daly, and she is currently handling with the Orbit 1 flight director on screen, who was Jeff Radigan. The Artemis 2 crew currently on board the craft. It continues to observe the eclipse that they are witnessing, so 43-minute eclipse period. This is Artemis Mission Control. You are currently seeing a live view of the solar array wing cameras on the Orion spacecraft. We spoke with our science team, and they did determine that that dot in the distance is Venus.
Science integrity. Let's see, not a huge change in here, just an update. The camera settings for Earthshine are challenging. This one's challenging to capture. What we're seeing, we're just not picking up on the cameras. And after all of the amazing sights that we saw earlier, we just went sci-fi. This has, it just looks unreal. You can see the surface of the moon between, I guess, the Earthshine. I guess Earthshine. You can actually see a majority of the moon. It is the strangest looking thing that you can see so much on the surface.
This is Artemis Control. You were just getting some communications call down from NASA astronaut Victor Glover. Currently on board the Orion spacecraft, they are currently observing an eclipse. There's about 39 minutes remaining in that eclipse period. Currently, we are in a forward link LOS, or loss of signal, so the crew can communicate down with...
He's seen 2 meteors. Science.
So we are to regain in about 3 minutes. At that point, I can communicate back up to the crew on board the Orion spacecraft. In the meantime, the crew can continue to communicate down to the ground. The ground is just unable to respond, so they are continuing to provide some science observations during this eclipse period. They've made some comments about Earth shine, which is the sunlight reflected from Earth when they come around to the near side in the sky window.
integrity in the blind. The glow on the moon is yanked a bit more even. So much distinct just where the sun set on the moon's horizon is where flying through the trajectory, and then the sun's going to come up out of the other side. I think it's we're starting to see the glow get balanced out. Because I still see Earth shine, or is it still quite
Integrity Houston, we have that sit rep loud and clear, and we are back with you. How do you hear me?
Hey Jenny, we have you loud and clear, thanks.
Copy. Victor, we're going to science for some quick questions. Thanks for your report. Integrity Science, we were loving your answer in the lines, and it should come as no surprise that we have a number of total questions. First, you mentioned Reed observing meteors. Can you speak to that? Or were you referring to comets or impact or something else?
Yeah, there's only seen 3 impact flashes so far. I saw 2 and Jeremy see 1 LED logical sequence for undoubtedly quick impact flashes. They were not something particular with clusters or perspective of flashes from this other one.
Amazing news. I literally just read and working up and down literally. You just mirror on the moon.
On the side of right. You're seeing them kind of on and south of the equator, kind of around the moon, or both of the equator, below the center of the moon.
News Reed and Ramon scientists on Earth looking for impact flashes. The reason on their side means that people.
This is Artemis Mission Control. We gained that also the team here is with the call up to the crew where the mice continue to flyby specifically in that period. So the science team here in Mission Control was able to ask them the they were providing during that loss signal. Specifically, they were interested in some of the meteors that they mentioned seeing and those impact flashes, and they did provide confirmation that they did see where flashes are lost.
And do you hear me?
One of the things which was surprising, the entire moon is glowing behind the entire moon. I thought it would look, against a box sky or deep space, but the sun's lighting up the entire moon. You can see the entire perimeter of it, and even now with the sun, you can little bits of topography, just bumps go around it. And there's about the glow around it, just as easily 10 times the diameter of the sun around the moon.
Incredible to hear me. You able to check out any external effects? And if so, I'd be able to for them in solar illumination.
No, we really haven't been able to identify features as you can see in our field. Like glow from a quarter moon, if you will, a glow perspective, and just very just angle. I'm just not able to tell anything.
Understood. Another question for you on solar drone. Were you able to see any structure or color in terms of them with a here?
Yeah, I think it's color, but definitely structure. I'm not sure we're not uniform at all. There was this constant change in intensity and diameter, but it was always there. It was always the 5 o'clock vision. I am on plume, and again, I'm going to be a position with
that we're looking for in that we calculated around about how long you could see the corona for, and we expect it to start to in the next minute. Thanks for the research.
We're excited to see again.
The recent rolling well that was ending. If you haven't already, reminding you to positions at the window and that you have really do a data reach change.
Okay, okay.
One request for you, while fresh in your mind, and in your strategies, you want what you're seeing either around the corona stars dimensions or even shine would be so appreciated.
Okay, Kelsey, it's going to be pretty hard to get you out what's my what we saw.
And if you have to come in and block for your cleaning application, or like
This is Artemis Mission Control. On the right, the officer console control, and agreeing the communication between the one officer is Kelsey Young, and then ask questions to the CSA astronaut Jeremy Hansen, based on the observations they've been making during this eclipse period. And in the upper left-hand corner of your screen, you can see a view of the Artemis real-time orbit website, which provides updates on these velocity and the distance and the moon of the Orion spacecraft as it continues to make its way back to Earth. The distance from the moon is increasing, so right now Orion is 100 miles away from the moon and about 200 miles away from the Earth.
Okay, science, we're getting set up for tonight's window teams. Our Christina is supporting and also the long lens and window and the short lens and window and we're getting window 3 and Edgardo is set up to see Corona.
Great, that sounds like a good config. We're showing Corona back start here on the minutes. How we start the theory operations.
This is Mission Control. We just heard the crew call down to the team here, reporting that they have stopped in the window for the final noted 1, noted 2, and reading which is the center of the year. There is about 18 minutes remaining in the eclipse period.
Obviously scientific value, but I'm really glad we belong here for probably it is truly constructive.
Y'all, consider what you see next.
Not sure if I'm sorry, but we can start rough the where I down rough the edge of the window like there's something on the left of the window and then orange the right of that so and so in Unreal the moon and the ground is the things we see out the window is kind of dark blue like it still stars quite a view.
Dicker science.
What he's doing is how long we look at our brains are not the same image in fact so we really don't need to invent what time we look out this window.
This is just asking people inspired here. Victor, we just what you're seeing is out in Mars, like Mars, to the picture of where
and from this point, 4 o'clock on the Earth's side is getting brighter, still no coronal structure.
Yes.
And we We are to Mars, Mars in the time.
This is Artemis Control, Houston, Texas.
We have not seen it by 5 minutes.
You had a pretty strong start, so.
Actually, right at this one. South pole on the result.
And as you look around, what are the patterns you find around?
We do. We've been watching close around. These are right tangible to the moon.
This is Artemis Control in Houston, Texas. We are currently 5 days to the Artemis 2 mission. We have London from the eclipse, so the latter half of the divide that the Artemis 2 crew is experiencing on the Orion spacecraft. We have current calls from the science officer in Seattle that they will see more citizens, and the scientists also confirm that they should be seeing something behind you. They've also acknowledged seeing several different impact flashes of lights from meteorites striking at the surface of the moon. They also mentioned the solar approach to the southwest atmosphere. Here in Control Houston, the two teams complete their handover. The two teams now leading here in Control, and here in Mission Control will be a test castle. And you see on your screen the right speaker console, and they far right of and test castle like that green.
Fourth position on the clock position on the side. Center to the second Mars towards the moon service.
Observations you can share that.
This is Control that you see on your screen from the solar array wing outside the Orion spacecraft. You can see that's starting to come into view. The solar series starting to end.
We should have several minutes before it's going to come. We should remind her here from 55. Because we could for several more minutes.
All things starting to be modern here. The density in the right molecule area is still the sun's brightness is definitely density.
I'm sure as the next more stream up.
This is Control in Houston, Texas. The two astronauts on board the Orion spacecraft are currently observing an eclipse. And the crew on board the spacecraft, the eclipse, much like a total eclipse, the moon is much larger than the sun, and like a terrestrial solar than the sun.
To see structure, there's rapidly rolling out toward 9 o'clock, 8 o'clock. As long as we're reaching the slower Earth. We've seen the top line of the top at night in Las Vegas. It looks like a wet house.
I'm glad you're following me.
So far, there are 2 or 3 chambers in the magnitude, and it's learning to pretty.
And integrity, we're for you approaching the brightness level, which you don't want to be on the 5.
And copies and thanks all his.
This is Control.
Combined with down toward the south pole and there's one large structure that was like 3 portions inside of his side and so the air movement was a very bright spot towering frame like and then 2 and that was just pretty bright.
We wanted to run on classes.
This is Artemis Control. The eclipse period is coming to an end, and we did call it that the crew must the eclipse and the two solar arrays on the Orion
starting for tomorrow. I'll have a you.
Team.
This is Mission Control on your screen. Log against the circle. Room here in Mission Control, Houston Hall from Flight Control Room.
Integrity change. Ring DAW 310 low on no for you. That will bring me a clip.
Okay, I think my question. Sorry, I'll look back.
We did it fantastically. This is how much team, the learning community, and what you will bring today. How you're welcome to us today and not say thank you. And find out more.
And our control, the winner of the is our control close at Eclipse, and there you can see what the evaluation more the sir was embedded in mission by science and by the library today. They also have a mission operations analysis, and of course we have the science of culture and the science of there on the corner screen. The science of the today as a Kelsey Young is their science obviously. And to her left is the OED answer for 2. And 7 hours everyone go through their by period. Now they will rather complete some final task and downlinking some pictures of the students that they did. And all the screen from the Orion spacecraft, I was already cameras. These photos did to be various lists towards the end of the 5 minutes when these sent from the opposite side of the perspective of the Orion space group. During time, mostly dark. The origin of these large sent down through all visible, and once the sense behind them, the crew looked for flashes, which they were multiple impact of the flash of them. They also looked for dust left above the edge of the moon. Along with starting planets, and just Mars off to the distance, also obvious on the way of the Orion area. The crew also eliminated by Earth time, because on Earth from the Earth control the moon side at the very end of the photo.
You will sit on and follow your reservations. I have to download that thing. We want to know the message about on board. Review your against that message. .store. The same item is that we have a deep list in previous events. So bring the HEK activity for us. F rate is set to 1300. It is at 10. We have the record that has down to one of the things that you. No,
this is Mission Communication American Carrier Mission 442 and the Sea Organization, the Ashton, they were 8%.
And integrity is important, so they were by this one.
The crew after the generation period was a 7-hour period of time which they were focused on reference by the science team here around they say here and they also running their with now the post their properties are going to integration they made to those to day. The science team here on the as much as and there will be posts by the crew and that's not a deep science team their new experience they're still in the field and they're still fresh. Of course they will also be a player downlink event now that the posts the activities currently they will have a medical conference or PMZ medical team. These are their summer conferences they have in the period and also a flight director will have before they go to period during which communication activities and personal activity has their sleep period.
And in 90 days, for Joe, thing.
I was started and audio is true, so I will give you a voice now on
Be good. In Houston, we like to see everything that's taken and
okay.
Copy. Great work, and good work, we like. And he said, we can't watch you, but you're going to and continue to I appreciate it. This part of the 40 days, hours, 20 minutes is part of the mission following the mass being there. I would say first, the coffee rank is wrapping up their lunar by cleanup activities there, making final. Video images from the eclipse on PPT 1 and the folder. We have 15 minutes. And that's actually on regarding public affairs, and that was captured during lunar activities. Just PPT, as far as the record book and punitive devices, which include tablets that are able to transfer files and procedures and timelines today. No. This is our control in Houston, Texas, here in Michigan, Georgia, that affect giant markets community users that the to grow is Tasco. On we write these programs for the observation period, they are completing activities and some data files down the ground following that lunar. Many of these files being science team overnight and some post lunar conference tomorrow was a up. The crew is also praying for having a sound gun, and that night they will have two final activities for the day. Practical team their standard conference at the end of every day. They'll also have a private conference with the contractor initial who go over the videos. Status and additions will start to make their flight. We are currently flight 6 and flash on April 10th. That's expected in days, 1 hours and 3 minutes from now. During the library, part of the student time with years directly invited community partners will be at the future missions. When premier record of full students and responder with the atmosphere for the in tax mechanisms or science consent day. See how science how involved, how the ministry how the chickens across and tools and there's information about others. The science artists on question answers from citizens and magazines data with real-time judgment context and adapted. Engineering needed evidence on the website. You have many information and ask slash documents, right based on the as well as DSR and the system of basic group. You can only write the news naturally begin with manipulation as Ash your government like two who are and Victor and entering the city. Further, based on 1,000 those over and this is all down at on person. There are about 8,000 away from noon. This is also increasing on return like other.
This is our days, 3 hours, 7 minutes into the fusion. Group going to stop the computer on vision period. We're going to fly by. Part of the flyby. The Orion star is going to be close to minutes, 467 miles away from us at approximately 6 p.m. 7 p.m. Eastern time. With the Artemis 2 mission, the RG-60 moon, teams are also going to experiment with themselves. Here's a little bit about another mission.
There's two humans to move flying around the moon on the ride, but along with that, a lot of great science.
What I think about research is that I'm actually unknown about why we explore our awareness. Because they say that we are testing it. We're testing science on word science where the astronauts experiments and from the knowledge that something that we observe.
We'll understand the environment, we'll understand the astronaut system, so these things are really perfect. And idea that when we go to the moon, we'll not be able to fly our exposure.
Much more research is very possible. We can't change the environment or control here. And the model is that we must we can change the earth and can make it just how much. So we can build out our work now. We can like that situation and that compares to national results. When they get sources of where we just not as well.
When we have how we track the internet, also we have to use the biomarker that's done hormone and body that I will share my body to the internet.
Will help us achieve our goals.
On top of that, to look at the moon, deep space, on our side over time over years.
And also rain on the moon is one of the reactions we're trying to do. You know, watching it so getting 2 seconds. So we get 2 to 3 people to have the video of the tell us about happening all the time. We're going to have an interview before. We're going to control that whole deal. We're going to